lesson is called Tangram Algorithms. A tangram is a puzzle with 7 pieces that can be put together to make other shapes. You'll be using an algorithm to explain to your partner how to put the puzzle together. An algorithm is just a list of steps that you can take to complete a task. We use them every day with things like shopping lists and recipes. If you keep an algorithm simple, there are lots of ways to interpret it, and whoever performs that algorithm might not get you exactly what you wanted. If you want to make sure that everyone ends up with the exact same thing, then your algorithm will need to be detailed and very specific. I'm using an algorithm today to complete a painting. So I wanted to try doing a painting of some wolves, but I'm not the most amazing painter. Luckily for people like me, there is paint by numbers. So there are 40 colors, and it has little letters and numbers that tell you which color to paint each of these sections. Paint by numbers tells me exactly what color to use and where. It's very specific, so I'm able to follow the directions and the painting will come out looking awesome. It's a great algorithm. If the instructions weren't specific enough, my wolves wouldn't look as good. So when you really want something to turn out exactly the way that you planned it, it's best to be extremely precise.
Good job.
One thing that computers are really good at is repeating commands. As a person, you'd get really bored if you had
this is the conditional block. It says, if you're at the flower or the honeycomb, then do something. So this is useful when we don't know how much nectar or honey to get, as we see here with this question mark. So in this example, we're going to say, if it's a flower, get all the nectar. And then use another one to say, if it's a honeycomb, make honey. Ta-da!
We have a new block that's called the if-else block. It's a conditional statement just like the if block that you've used in the puzzles before. But now there's a new part at the bottom that says else. The if-else block lets the bee make a decision between two sets of actions. If the bee is at a flower, the bee will do the set of actions you put in the first part where it says do. If the bee is not at a flower, the bee will do the set of actions you put in the slot where it says else. So if statements are how computers are able to make decisions. Humans set up conditions for the computer that say if the computer is presented with a certain situation, do this. Else, which just means otherwise, do that. The top of our if-else block says if at flower, but the top of our block could say other things like if nectar equals 2, or if there's a path ahead. And our block will behave in the same way, that if the statement on the top is true, it will do the first set of actions. But if the statement on the top is false, it will do the second set of actions.
You wouldn't even qualify for the race if you don't have people that are proficient in computer sciences because of how much data the cars collect and the necessity to be able to have people that can write programs to figure out how you can continue to build performance. In these puzzles, you'll be an artist that uses a pencil to draw different shapes, so wherever your artist goes, it will draw a line behind them. To move around the canvas, you'll use the Move Forward block. Here, the Move Forward block says move forward by 100 pixels. When we hit run, what happens? The artist moves forward a certain amount, and that amount is 100 pixels. Pixels are basically very tiny squares on your computer screen. The other block we have in this puzzle says turn right by 90 degrees. And when we drag that out, that makes our artist turn a certain amount. So you can play around with how far you want the artist to turn. This is a 90-degree turn. And this is a 120-degree turn. And remember, you can change these values by clicking the arrows next to the numbers for pixels and degrees. Enjoy drawing with your artist.
When you put a loop inside of another loop, we call that a nested loop. For example, here we're given the code already to draw one triangle with sides of length 100 pixels using the repeat times block set to 3, once for each side of a triangle. But we want to draw 6 triangles. In order to do that, we're going to take that loop and place it inside of another repeat times block. Pretty cool.
it.